Today we are going to start section 3. We're not going to forget about multiplying polynomials. As a matter of fact, we're going to continue that through this section. So to start off today, we're going to be talking about special products of polynomials. Alright, before we get into definitions of special products, I want to pose a question to you, or two. Is 2 plus 3 squared equal to 2 squared plus 3 squared? Okay, are we allowed to just square this part and square this part? Well, let's do some math. 2 squared is 4, and 3 squared is 9, which gives us a total of 13. However, here if we go order of operations and do parentheses first, we would get 5 squared, which gives us 25. These two are not the same thing. Okay, so is x plus 2 squared equal to x squared plus 2 squared? Based on this fact, this is not a property where we can do that because here we have two terms. Okay, so whenever we have that plus sign or minus sign, whenever we have two terms inside here, we have to use our distribution property, which is what we talked about in the last section when we were multiplying special products. We either have to FOIL or use our 2 by 2 chart, or just make sure that both parts get to the other both parts. Because this actually can be written as x plus 2 times x plus 2. Right? When you square something, it means you're multiplying it by itself twice. So here we're doing x plus 2 times x plus 2. And if that's the case, then we need to distribute the x to both parts and the 2 to x parts, which we would not get that as the end result. We would actually get x squared plus 4x plus 4. Okay? So today we're going to be talking about multiplying out these types of things, and there is a pattern that we can follow in order to do it. Okay? So, our first two rules, these are called perfect square trinomials. Okay? So here, when we have two terms in a parentheses and we're squaring it, what we get is a squared plus 2 times a times b plus b squared. If these two things are being subtracted, we get a squared minus 2 times a times b plus b squared. So the only sign that changes is going to be this first sign right here. Okay? So using this pattern, if we have x plus 4 squared, the first one listed is going to be your a. So a is going to be x, and b is going to be 4. Okay, so since I'm adding, I'm going to use this formula. So I'm going to have my a squared, which would be x squared, plus 2 times a, which is x, times b, which is 4, plus my b squared. Okay, so then we just simplify, and we get x squared plus 2 times 4 is 8, x plus 16. Done. Okay? If we have 2x minus 3 squared, our a is going to be 2x, and our b is going to be a negative 3. This is actually, well, it'll be 3. This is why we get the negative sign, because our b is technically a negative number. So if we just do it this way, using this formula, we're going to have a squared, which is 2x squared, you're squaring the whole thing, minus 2 times a, which is 2x, times your b, which is 3, plus your b squared. Okay? So here we get, square both parts, 4x squared minus 2 times 2 times 3 is 12x, and 3 squared is 9. Okay? That is how we can use our formulas in order to figure out these perfect square trinomials. Okay? Now, I don't want you to worry, I don't want you to have to memorize formulas if you're uncomfortable with that. So you don't have to worry, have no fear, FOIL is still here. Okay, so if you're faced with a problem like this, your x plus 4 squared, okay, you can easily just make your 2 by 2 chart, or you can rewrite it as x plus 4 times x plus 4 and FOIL it out. Okay? So if we did first, we would have x times x, which is x squared. Outer, x times 4, which is 4x. Inner, we get 4x. And then last, 4 times 4, which is 16. We can combine the middle two to be 8x, and we get x squared plus 8x plus 16. Okay, so we get the same thing, it's just one we used the formula, the other we didn't. Okay, now, you may FOIL so that you don't, or 2x2 chart, whatever you choose, so that you don't have to memorize the formula. However, you're going to need to start noticing patterns. Notice what these look like when they're done. Okay, we have perfect squares here, a perfect square here, perfect square, perfect square, perfect square, perfect square. You're going to start recognizing these patterns because when we go to factoring, which we'll get to later on in the chapter, being able to recognize these perfect square trinomials will be a great help to you. Okay? Alright, the last rule we have is something called a difference of two squares. Okay, so here we have a perfect square and we're subtracting another perfect square. Hence a difference of two squares. Okay? The way that you get a difference of two squares is when you're multiplying something with the same first and last terms, but in each parenthesis we have a plus and a minus. Okay? So let's FOIL this first one, or do a 2x2 chart so we can see what happens, and then we'll go on into the formula. Because here we actually get some very nice canceling, which is why we can just use this formula. Okay? So x times x is x squared, 4 times x is 4x, negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. Here, if we were to combine these like terms, negative 4 plus 4 is 0. So those go away, and we're left with x squared minus 16. Okay, that is our formula right here. We have our a squared minus our b squared. Okay, so using this formula, or just FOILing out, we can see that the cancellation happens. So now, in a sense, we can trust that the formula is going to work. Okay, so here, if your x is your a, and your 4 is your b, we're going to take a squared, which is x squared, minus b squared, so 4 squared, which gives us x squared minus 16. And that's the answer. Okay? With this one, our a is going to be 3x, and our b is going to be 1. So we have a squared, so we're going to have 3x squared minus b squared, which is 1 squared. If we simplify, don't forget your exponent properties, we have to square both parts. 3 squared is 9, x squared minus 1 squared, which is 1. Okay, and again, if you don't remember the formula, you can go ahead and FOIL it or use a 2x2 chart like we did here. But you want to start recognizing these difference of two squares because, again, that will be helpful later on down the road. Okay? So that is Special Products, Section 3. I'll see you later.